At home, you must have seen that especially in the summers and the rainy season, your mother is very careful about keeping things in the refrigerator. Why so? Due to heat and humidity, the food gets spoiled. The taste changes. And what happens if milk is left outside? It starts curdling. Even for curd, what she does? And after 5 to 6 hours, the milk has set into curd. What is all this? Okay, you take sugar, put it in a pan, after some time, and the grill is painted. Why is it painted? What are all these I am talking about? What I am talking about is the chemical changes. What is a chemical change? During which a new substance is formed. Now, how a new substance is formed? I will tell you. Then it is irreversible. We cannot change it. Just like when ice melts, it becomes water. But on freezing, water can change back to ice. However, chemical changes cannot be reversed. They are irreversible. Third, released. So these are some of the things that take place when a chemical change is taking place. Not only this, there can be a change of color, there can be a change of state, there can be change of taste, and so many things happen. Now, why do these chemical changes take place? That is what we are going to understand today. Chemical changes are there because some kind of reaction has taken place. A chemical reaction has taken place. What is a chemical reaction? Whenever two substances come in contact with each other, they undergo a change and new substances are formed. Now just imagine if you burn a matchstick, there is a flame and then some ash is produced. Now what happened in the two experiments that I showed you? In the first one, magnesium burnt with a bright light and then changed into ash. In the second one, when dilute hydrochloric acid was poured over zinc granules, then zinc chloride was produced and hydrogen gas was released. Now if you are supposed to explain this, how will you say? You will say the way I said. But isn't it too long? You know, chemistry is great. In chemistry, we are not so dependent upon conventional language. We can use shortcut. And what is that shortcut? We can say that magnesium, and for burning, which gas is needed? Plus oxygen gave us magnesium oxide. You don't need to say that magnesium wire burnt in the presence of oxygen to produce magnesium oxide. And what is this called? This is called a chemical equation. How will we define a chemical equation? It is a chemical representation of a chemical reaction. So what we have used is, we have just used the words, and whatever two compounds or two elements or one element and a compound combined with each other or reacted with each other, they are written on the left hand side. So on the left hand side, the compounds are the ones which are initial substances. These initial substances that react with each other are called reactants. And as a result of this interaction or reaction of reactants, the substances which are produced, they are called products, and they are written on the right hand side like this. So, in a chemical equation, these are the reactants and magnesium oxide is the product. Now what you have seen is there is a symbol of plus. Now whenever two compounds are reacting with each other and we want to talk about more than one substance, we put a plus. In the second case, dilute hydrochloric acid was poured over zinc granules. So what happened? Zinc plus hydrochloric acid and what did it give us? It gave us zinc chloride and hydrogen. Now in these cases what we see is that here we started with magnesium, a solid, oxygen, a gas, and what did we get? A solid. Here also we started with solid, that is zinc, hydrochloric acid is liquid, and what we got was again a solid and a gas. So what is the conclusion? That whenever a chemical reaction takes place, there is a change of state. Another thing that happened was evolution of a gas. In many cases, the temperature also changes. For example, if you put a drop of perfume on your palm, after evaporation, you feel cold, isn't it? Similarly, if you pour water in sulfuric acid, there will be lot of heat generated. You put water in quicklime, lot of heat will be generated. So much so, even when you are exhaling a part of respiration, if you do this, you will feel a little warmth on your palm. Why? Because heat is being released. So heat is either released or absorbed. In other words, there is change in temperature. Now going back to our first experiment, magnesium is a metal, so it has a luster. But after burning, it was white in color. Zinc is slightly brown in color, hydrochloric acid is yellow, and what we got was a colorless gas. So that means there is also change in color. So these are the four changes that can take place when a chemical reaction is taking place. Now going back to our equation. Here we were able to use a word equation, and that is a short form of talking about a chemical reaction. Can it be shorter? Yes, it can be. In chemistry, we don't have to depend upon conventional language. Chemistry has its own language. So, what we do? We can use symbol and formulae. Let us replace these words with symbols and formulae. Now, in the case of magnesium, the symbol is Mg. Capital M, as the first letter is always capital and second letter is small. So, Mg plus symbol of oxygen is O, and in the molecular formula it is written as O2. So, O2 leads to the formation of magnesium oxide. What is the formula? As both oxygen and magnesium have two valency, the formula will be as if there is only one atom of magnesium and one that of oxygen. So it will be MgO. See how small it has become? Now in the second case, zinc is Zn, hydrochloric acid is HCl, and what we get is zinc chloride plus hydrogen. it. No need to explain too much. From here we move on to the next step, that is balancing of the chemical equation. First of all, why balance? It has been observed that mass can neither be created nor destroyed. It remains same, which means the number of atoms of a particular element in a reactant will always be ultimately equal to the number of atoms of an element in the product, which means both sides have to be equal. It is something like a balance. You want to buy vegetable, what do? You tell vendor that I want 1 kilogram of potato. What he does? Puts potato on one side and then the weight on the other side and keeps on changing till both are equal. Sometimes he even says this, that okay, I can't remove or add one full potato, but what I will do is I will reduce the size to make it equal. Now we may not do exactly like that in balancing equation, but we'll do something of that kind. There is a proper method. It's not as if you can do haphazardly. So what we do here is, we'll take the case of some reactions. In these reactions what we find is that automatically everything is balanced. For example, if you put water in quicklime, of course lot of heat will be released. That is what we do before whitewashing. So in calcium oxide, when it combines with water, what it forms is calcium hydroxide. Now if we count the number of atoms in an element, say in the case of calcium, these are the reactants, these are the products. How many calcium atoms are there? 1 in reactant. Here also 1. Hydrogen. How many hydrogen atoms in water? 2. Here also 2. Oxygen. 1 atom is here, 1 atom is here. So 2 and 2, which means it is balanced. So in this case, we don't need to balance. Let us take another case. Instead of hydrochloric acid, if we pour sulfuric acid on zinc, then what happens? Zn plus H2SO4, ZnSO4 plus H2. The sulfate zinc has removed the hydrogen. So no problem, it is balanced. But in all reactions, it does not happen like this. In many cases, they are not balanced. For example, first let us take some simple cases. Now what happened when magnesium burnt? It was Mg plus O2 is equal to MgO. So although the number of atom of magnesium was same on both sides, but here oxygen atom was only 1. So what do? We take 2 molecules of magnesium oxide. So that makes 2 oxygen atoms. But then magnesium atoms have increased to 2, while here they were only 1. So we put 2. Same is true for calcium oxide. Or when hydrogen and oxygen combine, they form water. Now here oxygen atoms are 2, but here there is only 1. So if there are 2 molecules of water, we will get a balanced equation. After we have also taken 2 molecules of hydrogen. So here in these cases what we found, that we have always put the prefix in front of the compound. Why couldn't we do something like this? Then also it would be equal. But we can't do this, because this will make it hydrogen peroxide. This is not water. The formula will change. The atmosity will change. So we can only change the number of molecules or the number of atoms of an element or a compound. So that is why always the number will be written in front. Iron plus water gives us ferric oxide and hydrogen. Now how are we going to do it? So this time I will tell you the steps. First step is that we put boxes around the element like this. In the second step, we write down the number of atoms of every element. For example, we have iron, we have hydrogen, we have oxygen. Here are the reactants, here are the products. 1 atom of iron in reactant and in product 3. Hydrogen 2 and here 2. Oxygen 1 and 4. So this will be our second step. After we have done this, then what we will do is we will take up that element which has maximum number of atoms. Now which one has maximum number of atoms? Oxygen. So first of all we will try to balance the number of oxygen atoms. So third step will be balance the element with maximum number of atoms. So in this case what we will do is we will take 4 molecules of water. So this will make 4 atoms of oxygen here, 4 atoms of oxygen here. Right? In the fourth step we move on to the next element. Now by taking 4 molecules of water, hydrogen atom has become 8, but here it is only 2. So how many molecules of hydrogen we need to take? Again 4. Take second element. Next is the third element. Now we come back to iron. Iron, here there are 3 atoms and here we will take 3. Balance the third element. Finally, we will just check all the atoms whether they are equal on the right hand side and the left hand side. So here, now what is the situation? In reactants, iron is 3, product also it is 3. Hydrogen is 8, here also it is 8. Oxygen is 4 and there also it is 4. So the equation is balanced. So if we move like this, then we will be able to balance the equation. Now as in this method, we try again and again. This is called hit and trial method. So by this method, we can balance the equation.